Good afternoon, ladies and gentlemen. In this occasion, I would like to give a presentation about the research held by my team with the title Flare Potentiality Associated to Different Sunspot Groups During the Solar Cycle 24 observed by LAPAN Pasuruan. With me, Amatul Firdausya as the first author, Siska Filawati as the second author, and Silvi Oktavia as the third author. This is the outline of my presentation today. The sun has its dynamic to produce granulae, and then granulae mixed up together to create sunspot. The sunspot has bigger magnetic field but lower temperature than its surrounding. Sunspot observed by telescope and solar cycle is maintained the sunspot number. This is the sunspot number in solar cycle 22, 23, and 24 observed by LAPAN Pasuruan. The sunspot evolution can be identified by observing the changes in its shape, structure, and size from time to time that can be explained in the context of evolution of the active region. Sunspot can trigger flare, and flare is a sudden flash of increased intensity of radiation emitted in a short period of time in the surrounding of the sunspot area. The flare activity is closely related to sunspot. This is an image of a flare identified by high intensity. Sunspots are classified into some classes based on their appearance, including their size and structure. One method to classify sunspots into several classes is by using the Zurich classification created by Walt Mayer in 1938. Based on the Zurich classification, sunspots are grouped into 9 classes of A, B, C, D, E, F, G, H, and G. This classification scheme is made based on the morphology and the evolution of the sunspot. The sunspot data used is the sunspot data obtained from the observation by using a sunspot telescope at LAPAN Pasuruan during 2008 until 2019. The sunspot data recorded by LAPAN Pasuruan also including the Zurich classification of sunspot group. The flare data used was obtained from NOAA or National Oceanic and Atmospheric Administration archive from observation at X-ray wavelength by the GOES satellite. The data used are from the 24th solar cycle. NOAA flare data also includes the flare type, the flare class, and the number of flares in a year. A method we use to check whether the flare is produced by the sunspot is by examining the flare location and compare with the sunspot location. If they identified located on the same location, then we can make sure that these are both sunspot and flare are correlated. And after that, we analyze their class and properties. Finally, after we collect those data, we can make further analysis to find out their correlation. The solar cycle 24 has a period of around 11 years. The solar cycle began in December 2008 to December 2014, with a peak in May 2013. The peak has a sunspot number of 79. Meanwhile, the peak of the flares occurred in 2014 with an accumulation of 2,258 flares. The figure shows that the observation of the LAPAN Pasuruan sunspot with flare from GOES satellite data. It can be seen that the pattern of the flare events correspond to the sunspot number. Sunspots are grouped by Zurich class. During the 24th cycle, sunspot D dominate to produce flares compared to other sunspots. Except in 2014, the sunspot class that dominate flares is class C. It is known that 2014 number of flares was weighted highest during the solar cycle 24. Flare has the same pattern as sunspot. In the early phase of the solar cycle, the class B flare dominated compared to other class in a year. The flare B increased from 2008 to 2010, then decreased from 2011 to 2014 with a total of 240 flares. Increased again in 2015 to 2017, then decreased from 2018 to 2019. The flare C dominates the peak of the solar cycle 24 from 2011 to 2015. In 2014, the flare C has the highest number of a total with 1,797 flares. The total of flare triggered by sunspot shows that the flare potentiality by recognizing the surge class of sunspot. During the solar cycle 24, the most potential sunspot that produced flare was the D sunspot. The sunspot D has bipolar groups with penumbra and the size is less than 10 degrees of sun's disk. From all the analyses we've done before, we can conclude that the sunspot is closely related to flare, and the amount of flare that produced by the D, E, and F class sunspot dominates the flare production in solar cycle 24. During the 24th solar cycle, the class D sunspot dominate to produce flare compared to other sunspots. Except in 2014, the sunspot class has dominant flares is the sunspot class C. It is known that in 2014, the number of flares was the highest during the solar cycle 24. The C-class flare is dominating the entire flare produced in the 24 solar cycle. And at the peak cycle in 2014, the C-class flare is reaching its highest amount than the other years. From analysis, it is known that the C flare is mostly produced by the sunspot class D. The X flare is the strongest flare of all, and from data obtained, it is known that the X-class flare is mostly produced by the D class of sunspot, and it reached its maximum occurrence in 2014 or at the cycle's peak. And from all the explanation, we can make a final conclusion that strong flare that are the C and the X class are most produced by the big sunspot, that is the D, E, and F sunspot class. Moreover, the D, E, and F sunspot are the most potential sunspot that produce flare compared to the other sunspot classes. That is all about our presentation today. Thank you for your attention, and this is our reference that we use in our writing. Thank you and see you.